Section 8.3a is about scientific notation. Scientific notation is a way of writing numbers that are very large or very small. Now, scientific numbers look like this. Some number out front times 10 to a power. And one thing about the number that's out in front is it has to be between 1 and 10. So numbers in scientific notation have a number out here that's between 1 and 10, and you multiply by a 10 to some power. Now this 10 to the power is how you take a decimal point and you move it left or right, and we'll see in the next couple of examples how we're going to do that. One of the easiest ways to learn about scientific notation is to look at numbers that are in that form and then to write them in standard notation. Standard notation means just to write them like normal numbers without this 10 to a power. So let's see how that works. Right now we have 2.45, and we want to multiply that by 10 8 times, or 10 to the 8th power. So what we're going to do is take the decimal point and move it to the right 8 times, because each movement represents a multiplication of 10. So 1, 2, 3, 4, 5, 6, 7, 8. And every space that we create that doesn't have a number, we put a 0 in there. So we would say that 2.45 times 10 to the 8th, let's see, we're going to put commas, is 245 million. And there you go. Next one, 3 times 10 to the negative 5th. Well, where is the decimal point right now? It's right here. It's behind the 3 currently. Now this time it has a negative exponent. So in this case, we're going to go to the left 5 spaces. And put the new decimal point there. Fill it in with 0, so 0.00003 is what 3 times 10 to the negative 5th is. So if the exponent is positive, we're going to go to the right with our decimal. If the exponent is negative, we're going to go to the left. Some more examples here. So 0.000036. And then this one, 10 to the 14th. There's our last one. In these examples, we are asked to take a regular number and express it in scientific notation. So now we're taking these big or small numbers and we're writing them in scientific notation. And the key to this is remembering the phrase new to old. And the reason we have to do new to old is because when we create scientific notation, to put the decimal in the correct spot, you have to think backwards. And let me show you what I mean. Right now this number is 30,500. But to put a number in scientific notation, to go back to the definition here, the first number out front has to be between 1 and 10. Well, right now this number is 30 million actually, and it's not between 1 and 10 because the decimal point's right here. So where would we like our new decimal point to be? The answer is right here after the 3. So to rewrite this in scientific notation, we're going to use 3.05 because that is now between 1 and 10. But now we have to multiply this by 10 to some power. The question now becomes, what power do we put up here? Well, here's where new to old comes into play. You take the new decimal point, what I put in blue here, and you go to the old. 1, 2, 3, 4, 5, 6, so 7 to the right. And because I went 7 to the right, I'm going to make my exponent a positive 7. So this number in scientific notation is 3.05 times 10 to the 7th. Now that might look counterproductive because you might say to yourself, but we're not moving the decimal to the right, we're moving the decimal to the left, and you're correct. But to think about the exponent, you go from new to old, and that's why it's important to remember new to old for the exponent here. So let's try the next one. Where would the new decimal point need to be to make it between 1 and 10? Right here between the 7 and the 8. So scientific notation is going to be 7.81 times 10. So now we're going to go new to old. So that's 4 to the left, which means my exponent is going to be a negative 4. Now you can always check these numbers by actually taking the decimal point and moving it 4 to the left from here, and you'll see that you'll get the original number. Next one here, I'd like the decimal point after the 4. New to old, 11 to the left, so we're going to get a 4 times 10 to the negative 11th. And this one, new decimal point after the 3, 15 to the right, so we're going to get 3.002 times 10 to the 15th.